cannot provide assistance with examinations. It is essential to approach electrical code education with integrity and a commitment to genuine learning. Seeking unauthorized assistance on tests not only undermines the educational process, but also compromises professional ethics. The purpose of studying the National Electrical Code, or NEC, is to develop a thorough understanding of safe and effective electrical practices. This understanding is built through diligent study, critical thinking, and application of the code's principles. Relying on external help for exams bypasses this crucial learning process, leaving one unprepared for the real-world challenges of electrical work. Consider some core ethical principles. Firstly, honesty and integrity are paramount in the electrical profession. Electrical work involves safety-critical systems, and any compromise in ethical conduct can have serious consequences. Secondly, competence is another essential aspect. Electrical professionals must possess the knowledge and skills necessary to perform their duties safely and effectively. Passing exams through unethical means does not demonstrate competence. Thirdly, responsibility is critical, because electrical professionals are responsible for ensuring the safety of people and property. This responsibility demands a commitment to continuous learning and adherence to ethical standards. Ethical violations can have significant consequences, including damage to reputation, loss of employment, and legal repercussions. The National Electrical Code, or NEC, is a comprehensive set of standards for electrical installations. It covers a wide range of topics, from wiring methods and overcurrent protection to grounding and bonding. Mastering the NEC requires a systematic approach to studying the material. Start by understanding the structure of the code. The NEC is organized into chapters, articles, and sections, each addressing specific aspects of electrical installations. Familiarize yourself with the scope and purpose of each chapter. Pay close attention to definitions. The NEC contains many technical terms that have specific meanings within the context of the code. Understanding these definitions is essential for interpreting the requirements correctly. Study the general requirements. Chapter 1 of the NEC covers general requirements that apply to all electrical installations. These requirements include provisions for wiring methods, overcurrent protection, grounding, and bonding. Focus on specific articles. Within each chapter, there are articles that address specific types of installations or equipment. For example, Article 250 covers grounding and bonding, while Article 300 covers wiring methods. Work through examples. The NEC contains many examples that illustrate how to apply the code requirements in different situations. Working through these examples can help you to understand the practical implications of the code. Take practice quizzes. There are many resources available online and in print that offer practice quizzes on the NEC. These quizzes can help you to identify areas where you need to improve your understanding. Consider seeking guidance from experienced professionals. If you are struggling to understand certain aspects of the NEC, consider seeking guidance from experienced electricians, engineers, or instructors. They can provide valuable insights and clarification. Attend training courses. Many organizations offer training courses on the NEC. These courses can provide a structured learning environment and help you to stay up to date on the latest code changes. Now let's delve into specific areas. Let's consider overcurrent protection. Article 240 of the NEC covers overcurrent protection. Overcurrent protection devices, such as circuit breakers and fuses, are designed to protect electrical circuits from overloads and short circuits. Understanding the requirements for overcurrent protection is essential for ensuring the safety of electrical installations. Key concepts include ampacity, which is the current carrying capacity of a conductor, and the interrupting rating of an overcurrent protection device, which is the maximum current that the device can safely interrupt. Conductor sizing is another important topic. Article 310 of the NEC covers conductor sizing. The size of a conductor must be adequate to carry the load current without overheating. The NEC provides tables that specify the allowable ampacities of conductors based on their size, insulation type, and installation conditions. Consider voltage drop. Voltage drop is the reduction in voltage that occurs along a conductor due to its resistance. Excessive voltage drop can cause equipment to malfunction or fail to operate properly. The NEC recommends limiting voltage drop to a certain percentage of the supply voltage. Grounding and bonding are crucial for safety. Article 250 of the NEC covers grounding and bonding. Grounding is the process of connecting electrical equipment to the earth to provide a path for fault current to flow back to the source. Bonding is the process of connecting different metal parts of an electrical system together to create a low impedance path for fault current. Wiring methods need to be understood thoroughly. Chapter 3 of the NEC covers wiring methods. Wiring methods include conduits, cables, and raceways. The NEC specifies the types of wiring methods that are permitted for different applications. Understanding the requirements for wiring methods is essential for ensuring the safety and reliability of electrical installations. Equipment grounding is an important aspect of electrical safety. Equipment grounding conductors provide a path for fault current to flow back to the source, allowing overcurrent protection devices to trip and energize the circuit. The NEC specifies the requirements for equipment grounding conductors, including their size and installation. Bonding jumpers are used to connect different metal parts of an electrical system together. Bonding jumpers help to ensure that all metal parts are at the same electrical potential, reducing the risk of electric shock. The NEC specifies the requirements for bonding jumpers, including their size and installation. Let's consider some specific calculations. The NEC provides formulas for calculating voltage drop. These formulas take into account the conductor length, current, and resistance. Understanding how to calculate voltage drop is essential for ensuring that electrical equipment operates properly. Short circuit current calculations are important for selecting overcurrent protection devices with adequate interrupting ratings. The NEC provides methods for calculating short circuit current. Now let's discuss some specific examples related to the NEC. Imagine sizing conductors for a 20 amp circuit. According to NEC Table 310.15, B16, a 12 American wire gauge copper conductor with type TW insulation is typically suitable for a 20 amp circuit, assuming certain conditions. Now let's look at selecting an overcurrent protection device for a 15 amp circuit. A 15 amp circuit breaker or fuse is appropriate for a 15 amp circuit, ensuring that the overcurrent protection device is rated to protect the circuit conductors. When grounding a metal enclosure, the NEC requires that metal enclosures be grounded to provide a path for fault current. This is typically achieved by connecting a grounding conductor to the enclosure. Some common grounding and bonding mistakes to avoid include improper grounding of equipment, inadequate bonding of metal parts, and using the wrong size grounding conductors. Understanding the NEC is a continuous process because the code is updated every 3 years to reflect changes in technology and industry best practices. Staying up to date on the latest code changes is essential for electrical professionals. Common misunderstandings include misinterpreting the requirements for grounding and bonding and miscalculating conductor ampacity. Avoiding these misunderstandings requires careful study of the code and attention to detail. Remember, the goal is to develop a deep understanding of the code and its application. This understanding will enable you to make informed decisions and perform your duties safely and effectively.